Hey guys, this is the second part of the video titled Functions for Manipulating a Linked List. So in the first part of this video I talked about the first 5 functions which were insert at start, the traverse function, the search function, the print end function, and finally the delete at start function. So in the second part, that is in this video, I'm going to talk about the delete at end function and the rest of the other 6 functions. So now coming to the sixth function, the DeleteAtEnd function. So it is going to take the memory of the starting node of the linked list as input, and inside the function we're going to assign the starting node to the struct node pointer t. And first of all we're going to check whether the start is equal to null or not. So if the start is equal to null, then that means that the linked list is empty. We don't have any data or value present inside the linked list. So in that case we don't have to delete anything because we don't have anything inside the linked list, and we're going to print empty. We can't delete anything. But if the linked list has at least one node, then we're going to iterate till the second last node by making use of this while loop over here. The while t of next to next is not equal to null, then t equal to t of next. So after we have iterated till the second last node of the linked list, we're going to assign that node to the struct node star p, and we're going to tell the node next to p is null and t will go to the next node. And after that we're going to free the pointer t so as to delete the last node. So in this way we're going to delete the last node of the linked list. And now coming to the seventh function, the sort list. It is basically nothing but we're going to sort the values present in all the nodes of the linked list so that we get one ascending ordered linked list having all those values. So what I have done over here is that I have basically made use of the bubble sort algorithm. So basically the difference is that normally when we used to do bubble sort, we made use of simple integers, but in this case we're going to make use of pointers because we're dealing with a linked list, and the rest of the things are the same. If you come across this code, then you can see similarities, like the ing pointers are same as ing integers as in conventional bubble sort algorithm, and the t pointer over here is resembling the temp or the temporary integer which are used for swapping the values. So the rest of the things are the same, and after the entire linked list gets sorted in ascending order, we are going to print the message sorted. And now moving on to the next function, which is going to be our eighth function, the reverse list. So what we're going to do inside is that we're going to iterate right from the starting node of the first list, and in the process of iteration from the first till the last node of the linked list, we're going to store the data of each of the nodes and insert those data which we encounter in our journey at the starting of the second linked list. So what we have done over here is that as we iterate from the starting to the end of the linked list, we are going to use or make use of the insert at start function for the second start of the linked list, that is the start to pointer, and basically the reversed image of the first linked list is going to be the second linked list. So what we are basically doing is that we are not actually reversing the first linked list, we are storing the reversed image of the first linked list inside the second linked list, and we are going to print the reverse list is this. And now moving on to the next function, which is the insert at end function. It is nothing but we're going to iterate till the last node of the linked list, and we had already taken the node which we have to insert as the capital X node, as you can see. And after we arrive at the last node of the linked list, we're going to tell the next node to the pointer p is going to be X, and that's all. There's nothing new we have to do over here. It is the same only. We're going to go to the last node of the linked list and tell that the next node of the last node is going to be X, and the next of x is already assigned to null, as you can see over here. So this is what we have to do for the insert.end function and finally print inserted. And now moving on to the second last function, which is the delete from any position. It is a very important function because we had already seen the delete from head as well as the delete from end. Now if we want to delete any node from any position, then we have to first of all identify the starting node of the linked list as well as the value present in that node which we have to delete. So for that, we're going to run a for loop from the start node of the linked list, and if we encounter any conditions such as the node next to the current node contains the value, then we have to simply do t equal to I of next to next. So basically we are going to assign the next node to the pointer t. So next node in the sense it is the node which we have after the node which we want to delete, and we have to bridge the gap between the before node, between the node before the node which we have to delete and the node after the deleted node by making use of this line over here, I of next equal to t. And then we have to give the value 1 to the flag variable over here so as to indicate that we have deleted something. But if we don't encounter any such condition or the value itself is not present inside the linked list, then the flag's value will remain as it is, that is 0, and we can print couldn't delete. So this is how we can delete any node from any position inside the linked list. And now moving on to the last function for this video, that is the insert at any position. So for that also we have to iterate from the start node of the linked list, and if we encounter any conditions such as the node next to the present or the current node is equal to the after value, then we can assign t the value which is present after the current node, and the next of the pointer p is going to be t, and the next of the current pointer is going to be p. So in this way we can insert any node inside the linked list at that particular position. So here after value basically means the value which has to be after the node which we want to insert, and then we can print inserted and break from the for loop. And finally, if we don't find any such node as described by the user, we don't find any node having the after value, then we can print couldn't insert because the flag value is still 0. So these were the rest of the 6 functions from modifying functions of a linked list video. So that's it from this video, guys. I hope you enjoyed it. If you enjoyed my effort as well as my video, then don't forget to like, share as well as comment on this video and tell me what you like most about these functions, which is your favorite function. And if you like my effort in making all these videos for all of you, then please subscribe to my channel and give some love and support to all my other videos and all those playlists which I have on my channel. So thank you guys for watching till the end. I will meet you next time in the next videos. Until then, see ya and keep exploring.